If I ask you a simple question that what is hydrocarbon, then answer should be the compounds which is made up of only hydrogen and carbon. This is called hydrocarbon. Welcome to the second lecture of Aromatic and Aliphatic video series, and this is Fahad Hossain. Why hydrocarbon is important? Because we know that carbon is the element of life. And as we are studying about organic chemistry, we are studying about organic compounds, we need to concentrate the hydrocarbons, their types and the naming. The naming of hydrocarbons is a larger aspect and I shall explain it in the third video, but in this video I will only focus that the types of hydrocarbon and some part of its naming, the nomenclature according to the UPAC system. I hope you have already seen my first video where I have explained the vital force theory, the Berzelius and Friedrich Wöhler. So according to Berzelius, it was vital force theory, and then it was no longer accepted by the invention, after the invention of Friedrich Wöhler, and that was ammonium cyanide, which was organized as urea. And we know that urea is previously invented organic compounds from the urine of mammals. So we know the background. Now you see that what is hydrocarbon? Simply we know that hydrocarbon is made up of hydrogen and carbon. Okay, so simply we can divide it into two categories, that is aliphatic hydrocarbon and aromatic hydrocarbon. So I didn't write something about aromatic because it's another part or another area of organic chemistry. I shall explain later on. But before going to digging into aromatic compounds, we need to think about aliphatic. So why this aliphatic and aromatic comes from? So aliphatic comes the Greek word alipher. Alipher. So alipher means animal fat. Animal fat. So it's all about fat. And in other part, aromatic comes from the Greek word aroma. Aroma means fragrance. Fragrance or scent. Fragrance, something like beautiful, smelling. So aroma means fragrance or scent. And in other part, aliphatic, it comes from the Greek word alipher, which means animal fat. So simply we know that hydrocarbon is of two types, aliphatic hydrocarbon and aromatic hydrocarbon. Aliphatic is again divided into two different parts, that is open chain and closed chain. Now the question comes that what is the meaning of chain? Students, those who just started this chapter, I'm again saying that those who are just starting this chapter, please concentrate each and every single lines of your books. Do not skip. This chain means there is a property of carbon to be bound to each other and create a long chain, and that property is known as catenation. I shall explain it later videos. That is, catenation is the properties of carbon. The properties of carbon that it can bind together and create a long chain like this. So each of carbons are connected each other through a covalent bond. We know that carbon, the positions of carbon in group number 14, we know that there are 6 protons and 6 electrons of carbon. So outermost shell has 4 electrons. So carbon can add with 4 hydrogen, and that is the methane. Methane, we know this is CH4 methane, and this methane is the first compounds of the organic chemistry, and you can say this is alkane, the first member, the primary member of alkane, that is methane. So this methane comprises of 1 carbon and 4 hydrogen. So simply we know that 1 carbon can attach another 4 single bond hydrogen, and this is methane, and that is why this is hydrocarbon, because these compounds are made up of only carbon and hydrogen. So I'm coming with a lot of explanation after that. Before going to explain, these properties of carbon making chains is known as catenation. So that is catenation. Now is tell me one thing, that this is catenation, okay, and for these properties I already said in my previous video that catenation, isomerization and polymerization are three properties, and that is why the number of organic compounds are much more than comparatively inorganic compounds. We know that number of organic compounds is nearly more than 8 million compounds are there. Because of this, inorganic compounds cannot create this long chain, but carbons in organic compounds, this carbon can create a long chains between them, and it is actually the covalent bond. So due to this catenation, the chains are like this, and two types of chains are there, that is open chain and closed chain. If this carbon looks like this, then we can say that this is a cyclic order. All carbons are attached together, but there is no terminal carbon. But here you see this is open chain because there are two terminal carbon which are not connected. So when the terminal carbons are not connected, these are open chain aliphatic hydrocarbon. Very simple. And when there is a connections in between them and it's create a cyclic structure, then it's called closed chain aliphatic hydrocarbon. And you see again both chains are divided into two simple parts, that is saturated and non-saturated. Saturated means very simply where there is single bond. Mind it, saturated means there are carbon-carbon single bond. There are carbon-carbon single bond, that is saturated, and where there is double bond and triple bond. When there is double bond and triple bond, this is called non-saturated hydrocarbon. I'm thinking that those who are watching right now, you will have started from very beginning, and then the journey will require a lot of things coming up next. So the next video would be the naming of hydrocarbons, the naming of alkane, naming of alkene, naming of alkyne, and so on. And we have to understand the number of carbons, the numbering systems, the substituent, and relevant other things. So saturated means there is single bond between carbons, So if there is carbon-carbon single bond, this is saturated aliphatic hydrocarbon, and if it is like that, this is open chain, and if it is like that, this is closed chain. And right now this must be said that the numbers of carbons, it actually define the naming of the compounds. You see something like that in the right part of this board is written the number of carbons simply, and the prefix of those numbers, that prefix is important. You see, that is meth. So when you say meth, that is number 1, 2, eth, prop, but, penta means 5, hexa means 6, hepta 7, octa 8, nona 9, and deca 10. So when there is something like that, we are saying the number of carbons is 10, we'll definitely think about the number of bond later on, but previously the number of carbons, we must count it first to identify the name of that compounds. So you see the number of carbons here, that is open chain. So 1, 2, 3, 4, 5, 6, 7, 8. So this is octa. And there is single bond, so we can say this is saturated. As this is single bond, we simply can say this is octane, if there is no other carbons associated with that. So if all the carbons, you must know one thing, that every single time we must remember one thing, that the valence electron of carbon is 4, so the valency of carbon is also 4. So the number of bond with all carbons should be 4. So that is why you see that this carbon, it has single bond with the right side of its carbon. So 3 other hand is vacant. So this 3 hand would be associated with hydrogen. And you see the next part, that this carbon, it's connected already 2 hands. So 2 other hands is vacant. So there should be hydrogen. Similarly, till the last part of it, it would be CH2, 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 and the last part should be CH3. And that is why this is called octane. We must say this is octane. Why octane? We said it, this is oct, O-C-T, oct, because of there is 8 carbons are there. So number of carbons are 8. That is why we will say this is oct. But after, it can be octane, it can be octene, octine, octanol, octanoic acid, depending on the functional group. What is functional group? I'll come up later on, because some of you may know it, a functional group, that group which will be functioning, and that determines the properties of that compounds, that is functional group. There would be another individual class on functional group. Some of you can see it, or if you know it, thanks a lot. Now you see number of carbons are 8, and this is closed chain. Now if there is closed chain, so number of carbons are there 4. So this is but there is more. I mean, we must ensure hydrogens are occupied with all carbons. So these carbons are there. So it looks like what? It looks like CH2 bond, CH2 bond, CH2 bond, CH2. And as all the carbons is in a cyclic order, the name of this compound would be cyclobutane. So this should be cyclo, no space, cyclobutane. Why this is cyclobutane? As because there is no double and triple bond here. So if there is a single double bond or triple bond, if there is a double bond, what would happen? If there is a double bond, so this carbon is occupied with 1, 2, 3 and 4. Similarly, this carbon would be occupied as 4 valence electrons. So now you see it's become CH, CH2, CH2 and CH. This is cyclobutene. We can say this is cyclobutene. Now you see that after but, you see this is but. The number of carbon is 4. Here also 4, but this is saturated because there is single bond in each carbons. Here there is a double bond in between 2 carbons, and that is why it's called cyclobutene. So after that, this ene, it means that this is the member of alkene group. This is the member of alkane group. Okay, so when carbon creates this long chain because of the catenation properties, and this catenation is one of the main reason that the number of organic compounds is much more than the inorganic compounds. Now you see, if I write something like that, I mean, think about saturated and non-saturated, where there is double bond, 1, 2, 3 and 4. Now you see the number of carbons are 4. Okay, number of carbons are 4, and this is open chained because the terminal carbons are not connected to each other. As what should be the name of it? I'm not taking the class of naming of organic compounds, but this is very important. As this is open chained and there is a single bond, so this is non-saturated aliphatic hydrocarbon. Unsaturated because there is single double bond. So as it has 4 carbons, we can see that 1, 2, 3, 4, this is butene. It should be butene. And simply I can say that the double bond is just corresponding to the number of 2 carbon. It can be butene 2. And if it happens in cyclic order, then it would be cyclobutene. So it can be like that when there is 3 carbon, 1, 2, 3 in an open chain form, and there is single bond. This is saturated aliphatic hydrocarbon. So the number of carbon is CH3, CH2, CH3. So when we'll write like this, CH3, CH2, CH3, we can say this is open chain, and there is no double and single and triple bond. So this is saturated. So saturated aliphatic hydrocarbon names propane. We say this is pro, as because the number of carbon is 3, it should be propane. And if it happens in a cyclic way, like this, then it creates a cyclic order, and then CH2, CH2 and CH2. The name of these compounds is cyclopropane, as because in a cyclic order. But if there is a double bond in between them, so one bond would not be here, as because we must concentrate every time that the valency of carbon should be 4. It's there. So 1, 2, 3, 4. 1, 2, 3, 4. Now it becomes cyclopropene. It becomes cyclopropene. So at last of prop, the word prop, we said it's in, as because there is a single double bond. So when there is double bond, we must consider this as a member of alkene. When there is a triple bond, we must know this is the member of alkyne, and these are the functional group. And coming up with the next video regarding these naming, but these are all the types of hydrocarbon. So whenever you see there is single bond, saturated, saturated. And when there is double and triple bond, non-saturated. And you must count the number of carbon every single time. Okay? Let's count the aromatic compounds. What is aromatic compounds? I already said that aroma means fragrance. Fragrance means that is smells good. And this is Greek word aroma. And what is the properties of it? Aromatic compounds, that is actually, it has some properties. Number 1, this cyclic coplanar cyclic compounds. Coplanar cyclic compounds. Number 1. Number 2, that is the first member of aromatic compounds, that is benzene. So this is all about benzene and its derivatives. Benzene and its derivatives. And it has 4n plus 2 numbers delocalized electrons. Now you must say, what is 4n plus 2? What is the mystery of it? It's all about Haeckel theory. So I shall explain it. What is Haeckel theory? Just for this purpose, for this class, I'm just saying it. The aromatic compounds, we can identify the aromatic compounds based on some properties and some factors. That is, it's coplanar cyclic compounds, benzene or its derivatives, and lastly we can say there is 4n plus 2 numbers delocalized electron would be H carbons. I mean the number of carbons, it requires individual classes. What is 4n plus 2 and why it comes from. So 4n plus 2, the Haeckel theory I shall explain in individual videos. Now you see how benzene forms. What is benzene? You see that benzene is C6H6. But if it would have C6H12, then what will happen? You see that 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Suppose this is a cyclic order. and each carbons, it has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 carbon. So every time you see that carbon is occupying with corresponding valence electrons. In these compounds, can you see any double bond? No. So this is not aromatic compounds. Why? As it's cyclic, but it's not aromatic. This is aliphatic, and this type of compounds is known as alicyclic compounds. Alicyclic compounds. Alicyclic, and this is called cyclohexane, not benzene. So whenever you see that C6H12, that is cyclohexane. So this is cyclohexane, and this is close chained aliphatic hydrocarbon. But when we'll study about aromatic, there is something special. So 1, 2, 3, 4, 5, 6. There is also 6 carbon in a cyclic order, but there should be an alternative double bond. So 1, 2, 3, 4 and 5. Now you see there is alternative double bond within this carbon, and it has 1, 2, 3. So there should be one single hydrogen in each carbon. So according to this structure, we can see the number of carbon is 6, and also the number of associated hydrogen is also 6. So this is C6H6, and it's called benzene. So benzene and the benzene derivatives compounds are called aromatic compounds, and these are actually beautifully smelled, and that is why it's called aromatic compounds. But not all compounds are beautifully smelled, some of them. So this is benzene, and if you see that another structure is added with this, something like that. When we draw this, each corner represents the carbon. Each corner represents the carbon, and you see this is 4n plus 2. I mean, well, the alternative double bond is inside. That is represented by a circle. That is called the resonance, and this is benzene in short. So if there is another circle is added with this, then you count the number of carbons. Total 6, 7, 8, 9, 10. There is 10 carbon, but only 1, 2, 3, 4, 5, 6, 7, 8. 8 hydrogen. So there is C10H8, and this is naphthalene. If there is again another circle is added with each, so 3 benzenes together. Now it's called anthracene. So aromatic compounds, again a beautiful and interesting part, but no, in this series I shall explain aromatic compounds after explaining all this functional group like alkane to aldehyde to fatty acid to amine. So my target was to explain hydrocarbons very simply and their types in this video. So I hope those students, teachers, or even parents, and those are watching right now, I have a very simple request to you that nothing should be left from this chapter. Nothing. Every single thing is important. What is aromatic compounds and what is aliphatic compounds, I explained shortly. But when we will study about aromatic compounds classification, that is a more in-depth. So 2 types, and there are more other types will be derived from that part. So according to the level of explanation in this chapter, I shall try to remain very simple. And aliphatic and aromatic compounds was defined in this. So open chain and closed chain, idea is clear. Open chain can be saturated and non-saturated based on the bond. If there is single bond, saturated. Double and triple bond, non-saturated. And this cyclic order doesn't always mean aromatic. So it can be cyclopentane, cyclohexane, cycloheptane, but when it is aromatic, there is something we must consider: the double bond. It has its alternate position and its benzene ring. When some sort of alkyl is added to that benzenes, the naming of aromatic compounds depends on this. So what is alkyl? One hydrogen less from the alkane is the corresponding alkyl. So I hope you can remember this series. This is the prefix series of naming of organic chemistry. You must remember meth, eth, prop, but, pent, hex, hept, oct, non, dec. And number 11 is undec and 12 is dodec. When there is alkane, carbon-carbon single bond, depending on the number of carbon, we say N after that, double bond in after that, triple bond ein after that. Okay, I shall come with more explanations accordingly, this individual alkane, alkene, alkyne and alcohol later on. So see you on the next video. Take care, stay well, and if there is any problem, if you feel anything, what about, I'm trying my level best. Sometimes you people might have some different understanding and opinion. Please let me know, and I would take positively if there is anything you want to say. Put comments in the comment sections from YouTube or even Facebook, whatever you are saying. Take care, stay well.